Good morning, students. Today we are going to start with digital voltmeters. Under the digital voltmeters, there are different types of digital voltmeters such as RAM type digital voltmeters, successive approximation digital voltmeters, integrating type of digital voltmeters, continuous balanced digital voltmeter, and so on. First of all, we will learn RAM type of digital voltmeter as given in the circuit in the block diagram. RAM type of digital voltmeter is relying upon a certain sawtooth waveform. It is type of analog to digital converters, or say where it needs certain pulse. The operating principle of RAM type digital voltmeter is based upon the measurement of the time it takes for linear ramp voltage to rise from 0 volt to certain level of the input voltage, or to decrease from certain level of the input voltage to 0. This time interval is measured with an electronic time interval counter, and the count is displayed as a number of digits on electronic indicating tubes. Conversion from voltage to time interval is illustrated by the waveform, and at the start of measurement cycle a ramp voltage is initiated. This voltage can be positive going or negative going. The negative going ramp is continuously compared with the unknown input voltage. At the instant that the time voltage equals the unknown voltage, a coincidence circuit or a comparator generates a pulse which opens a gate. This gate is shown in the block diagram. The ramp voltage continues to decrease with the time until it finally reaches to 0 volt, and a second comparator generates an output pulse which closes the gate. An oscillator generates clock pulses which are allowed to pass through the gate to a number of decade counting units, which totalize the number of pulses passes through the gate. The decimal point number displayed by the indicator type tubes associated with the DCU is a measure of the magnitude of the input voltage. The sample rate multivibrator determines the rate at which measurement cycles are initiated. The oscillations of this multivibrator can usually be adjusted by a front panel control marked rate from a few cycles per second to as high as 1000 or more. A sample rate circuit provides an initiating pulse for the ramp generator to start its next ramp voltage. At the same time, a reset pulse is generated which returns all the DCUs to their 0 state, removing a display monitor from the indicator tubes. I'm repeating again in brief. When DC input we want to measure, that is provided to a ranging and attenuators. These rangings are from 0 to 0, 1, 10, 100 and so on ranging. It gives input to a comparator, first comparator which is a top comparator, and a generator starts comparing with the input sawtooth wave generated by the RAM generator. If it exceeds more than the RAM generator's input, it starts generating a pulse. Input comparator 1, top comparator gives start pulse to a gate, and starting of the pulse is started. At the lower ground comparator level, when it reaches, the RAM generator reaches 0 volt, it gives one stop pulse to the gate, on which gate will become closed. Oscillator pulses are passed during this time period. If it is a 1 second time period, it passes suppose 10 pulses, 10 oscillator frequencies, then that 10 is nothing but a voltage that has been counted, and that is converted into counter and it is read out digitally. That means number of pulses within 1 second is counted as voltage available at the input side. Next part we will learn in the next lecture. Thank you.